Okay, matrix, let's now continue with this trigonometric. A very nice, straightforward and simple questions. This is the questions that is coming at the first question that is given as trigonometric. Sometimes it's question 5 and sometimes it's question 6, depending on the question paper. Now, look at this question. The first one that we have done, the diagram was drawn for us and was straightforward. Now the diagram is not there. What are they saying now? They say, if you are given cos of 2 theta being equals to negative 5 over 6. So it's still on question 5. So let's write that question down. We are still in question 5. Okay. And the information, therefore, it says, if cos 2 theta is equal to negative 5 over 6. And it's not ending there. They said where 2 theta, it is in a boundary of, or is an element of 180 degrees and 270. So you need to remember where that is. 180 to 270, it is on the third quadrant. Because when we draw a Cartesian plane, we read 0 to 90 to 180 to 270 and complete it at 360. So that's where your 180 is, and that is where your 270 is. So whatever you're talking about, it is between this third quadrant. Okay. Now they said calculate without the use of a calculator. So we're not using a calculator again, but we have to find the value of something else. So when you see these kind of questions, just before you do anything, you must represent this information in your diagram, always. So this is the diagram on a Cartesian plane. What are they saying? Whatever it is going to be on the third quadrant. My diagram is going to be a right angle, the triangle there. Okay, where is the angle 2 theta? The angle 2 theta we are talking about is the one that is there. So this is where 2 theta is, this angle there. Okay, now we're given that it's going to be equals to a negative 5 divided by a 6. Now, go back to our basics. Remember that if you had a Cartesian plane with a right angled triangle with r, x, and y, where this is theta, your cos of theta will be adjacent over hypotenuse, meaning it's x over r. That means that negative 5 represent your x, while 6 represent your r. So that's what you're going to do on the sketch. You must label them as such. Look at this. Your negative 5, it's going to be in the x-axis because represent x. And your 6 is going to be the r, which is your hypotenuse. What are you looking for now? It is your y. Your y is now missing. You need to find the y. And before you can even look at the question, by representing that is telling you that y is missing. Immediately so, use Pythagoras theorem and then find the missing side. So let's do that. If we use Pythagoras theorem, we'll have, remember it's r squared equals x squared plus y squared. So our r is 6 and our x is negative 5. This is equals, and we are looking for y. And this is going to be 36. That's 25 plus y squared. So 36 minus 25 will give us how much? So this is 36 minus 25 equals y squared. Y will be equal to the square root of, remember it's y, so it should be plus or minus. The only thing that comes positive, it is always r, because r is a radius. Radius cannot be negative. So with y and x can be negative depending on the side where you find it. In the third quadrant, both x and y must be negative. So you can quickly run to your calculator and then make sure that you get it right. So here we go. We're having the square root of 36 minus 25 and gives us the square root of 11. Now you go to the Cartesian plane and check. In that means y is going to be equal to negative the square root of 11 because we're on the negative side of the y. So there your y, therefore it's negative the square root of 11. We haven't yet looked at the question, but you have done this all, and it consists of marks as well. By showing this, you have some of the marks already before answering the question. The question number 5.1.5.1.1, so it's 5.1.1, says that we have to calculate without using the calculator the value of, in the simplest form, of sine 2 theta. So that's what you're going to write. What is sine 2 theta? Remember our angle is 2 theta. So sine 2 theta, it is opposite over hypotenuse. So it's going to be a negative the square root of 11 divided by 6. And this one is 4 marks. Folks, the 3 marks will have run through this 2 that you have started with, and then the other marks will come to that part. Okay, 5.1.2. So let's go to 5.1.2. They said you must find what? Sine squared of theta. Sine squared theta. Folks, bear in mind that your diagram does not have theta, and you cannot create theta in the diagram. So you must do something to get to that theta. How do you do it? Your formula sheet is a key. Go to the formula sheet, check what is it that can relate to the sine squared of theta in terms of 2 theta. So somehow you'll have to change it and put it where it's supposed. So your formula sheet here and information is very important. So let's look at it. If I look at sine squared theta, I can try to change it using anything. For now, I can go to the formula sheet and check cos 2 theta. Remember, it has 3 things. So it can be cos squared theta minus sine squared theta, or it can be 1 minus 2 sine squared theta. So if I use 1 minus 2 sine squared theta, have you guys realized that already I have what I'm looking for? Sine squared theta. What I need to do is just to make it the subject of the formula and get to the solution. What is cos 2 theta? Cos 2 theta was given to me as negative 5 over 6 there at the first statement. So that's what I'm going to do. This one I'm going to substitute it by negative 5 over 6, and I have 1 minus 2 sine squared theta. Remember, we are looking for sine squared theta. So this is our key where we want to go to. Okay, so we'll have to work it out, play it around until we have sine squared theta equals to something. So this is, let's take out the 1 to the other side. So it's minus 5 over 6 minus 1 equals minus 2 sine squared theta. We still don't need the minus 2, so it means we have to take it to the other side as well. So we are going to divide both sides by that minus 2. So if I divide that by minus 2 and divide the whole thing by minus 2, the minus 2 will cancel with the minus 2. Then I remain with sine squared theta. With you guys, you can go in and then use a calculator. Then you'll get what sine squared theta it's equals to in terms of that. Punch it as it is on the calculator. Just use your fraction buttons twice, and it will give you what you are looking for. So it's, let me quickly do it on the calculator so that we don't waste time. Remember, calculate is one of the things that saves time. So it's giving me 11 divided by 12. So that means that sine squared theta is equals to 11 divided by 12. They just tricked you, knowing that you'll end up taking this and use 2 theta and forget that you are dealing with theta. So you must first change it to this, which is part of your information sheet, and then come to the solution as it is. So this is the answer. Sine squared theta is equals to that. So with 5.1, we are kind of done with it. So this was 5.1. Let's go to 5.2. And now 5.2 is out of what we were doing. 5.2 is something else. Let's look at the question. Folks, this one needs focus, concentration, and some of the information that you have to revise. Now, this is what makes trigonometry looks difficult or complicated. It's because most of the information you must try to bring it on by the time you are writing. So you must try to practice it as much as you can so that this information stick to your head. Okay, now let's write the question down. In this one, they say simplify. Now, simplify simply means do something until you can't do anything. You must simplify this to a single trigonometric ratio. Whatever you do, at the end, you have to have one single trigonometric ratio. Folks, single trigonometric ratio means you have to end up your answer with either tan of something, cos of something, or sine of something. Not 1 plus, 1 minus cos, 1 minus tan. It has to be one term. So it's either it has been divided becoming one term or something like that, but you cannot have 2 terms. That is the meaning of one trigonometric ratios. Okay, let's write the question down. They said is sine, it is sine 180 minus x, and it's multiplied by cos of negative x, and it's added to cos 90 plus x. And we're going to take it a little bit down to continue, but then it's multiplication. It's multiplied by cos x minus 180. Remember, this is on the same line. Okay, having it like that, we must simplify and make sure that we get one trigonometric ratio. So let's start. In here, if we look at it, we are not doing something that we don't remember, because when you reduce in grade 11, we're using this Cartesian plane with 180 plus or minus, 360 plus or minus. So we are doing that here. We're going to say 180 minus x. Where in the Cartesian plane I'm going to find 180 minus x? It is on the second quadrant. Is it sign positive or negative? My sign is positive, so that is going to be just sine x. And you multiply it by cos. Remember, folks, negative angle is in the fourth quadrant, and in the fourth quadrant, cos is positive. That Cartesian plane, some people call it cast, some people call it many other things. So maybe we can try to draw it here and remind ourselves about it. This is cast. And my student says, all silly teachers complain, and some says, all students to copy, and some student, one of my students say, allow students to copy, especially in maths, because they are failing it. So if we allow them to copy, they can get it right. So this is the slogans you can try to use and remember what you are saying. Whatever works for you, you can use it. So when I say sign is positive, I'm talking about where is in the second quadrant. This is the quadrant I'm talking about. So that is why we ended up with the sign x. Remember, we say this is where 0 is, this is where 90 is, and that is 180, and that's 270. Then we end up with 360. Okay. So the minus is here. 180 minus is on the second quadrant. Now, the fourth quadrant has the negative x. That is why we are saying the cos will simply be a positive cos of x. Okay, folks? Let's go to the third one. Okay, they said plus. Cos 90 plus x. Now, cos 90 plus x, it has a partner. The moment it is starting talking about 90 and 270, it's married. Now it's talking with the other partner, which is now sine. If it's just cos, remember cos, if we call it fully, it's cosine. So if it's sine, it means its partner is going to be cos. If it's cos, it means they are together. Now it's cosine. They're now married. Now you have that cosine. You need to take the wife and leave the husband, the cos. You use the sine. So it means that we are going to use sine. However, while using the sine, we have to look at the fact that where do we find cos and where do we find 90 plus? Remember, 90 plus is on the second quadrant. And on the second quadrant, only sine is positive. Cos is going to be negative. That makes our sign here to be a negative sign. So you need to be careful of this thing. You need to take note of it because it's very important and it can make you lose marks. And now, look at the last one. That is cos x minus 180. We are used to 180 plus 180 minus. But we can break that because it's just what we are used to. We can still make something out of it. Let's see. If I have x minus 180 and then I rearrange it, I'll have negative 180 plus x. If I take out the common factor, I'll have negative 180 minus x. Can you see if I multiply this, I'll go back to what I have. So it means what we are going to do with this is actually this part. Okay, so we're going to put our cos, put a negative, and also the angle 180 minus x. Remember, folks, negative is in fourth quadrant. Then that means cos is going to be positive. So that is your first statement. You'll have cos of 180 minus x. You can write it within the statement, but sometimes there's no need for you to. You can do it aside. Then having it like this, we go to the second quadrant where cos is negative. So this has become negative cos x. Do not confuse this information. It's very important for you to be alerted about it. So we are going to multiply this with a negative cos of x. And that is our first part of simplification. Then we start multiplying out the negative. This is sine x times cos x. The negative times a negative will give me a positive. So we remain with positive sine x times cos x. Now, if you look at it, we have cos x, sine x, sine x. It's like we are having x and x, if you look at it like that. So we can add them together, for which we'll have 2 sine x cos x. Now, 2 sine x cos x is written in your formula sheet to say this is the double angle of a sine. So you can write it as sine of 2x. Can you see now you have your single trigonometric ratio, and then that's where you'll get your full marks in total. Okay. Let's see if there's another question for this one. I guess that was the last question for this, and it was 6 marks. Look at it. It's just as small as it's just that this information must be inside your head for you to be able to get this full 6 marks. Okay, thank you, folks.